Okay, so now we're going to look at the real world example. So these are just word problems. It says a student lives 4 miles from the middle school. She rides her bike to school every morning at a rate of 1 mile every 6 minutes. The distance she has remaining, y, is a function of how long she has been riding her bike. Okay, so we've got to figure out if this is discrete or continuous. So am I going to list out my x values, or am I going to write them with inequalities? So what I want to look at is I want to look at my x values, because that's going to tell me if this is continuous or discrete. So it says how long she has been riding her bike x. So if I think about how long, that's talking about time. And when we are measuring time, there is no skipping of x values. If you are running a race with your friend, and they are timing you from start to finish, that stopwatch is using every place value for time from the time you start the race till the time you cross the finish line. It's not going to leave out any time numbers. So this would be a continuous domain, which means I'm going to use my greater than, less thans. But first I need to figure out some values. So we know that x has to do with time and y has to do with how long she has to go, like how far she has to go, the distance she has left. Okay, so if she hasn't started her journey, time is 0, how long does she have, what's the distance she has remaining on her trip? Well, the distance is going to be 4 miles because that's how long she has, how far she's got to get to school. Okay, she hasn't traveled any of that. So we want to get down to when she's at 0 miles. We know that she is at school. We just need to know how long that time is. So let's think. Okay, so if she has 3 miles left, she has ridden for 6 minutes. Okay, so 3 goes with 6. If she has 2 miles left, she's ridden another 6 minutes, that'd be 12. When she has 1 mile left to go, she's gone another 6 minutes, which is 18. And then when she has 0 miles left to go, she's at the school and she has traveled, or time has passed, it's been another 6 minutes. So it's really 24 minutes that it takes her to get to school. 6 minutes for each mile, and she has 4 miles to go. So that would be 6, 12, 18, 24. So her domain is 0 is less than or equal to x is less than or equal to 24, because I'm going to include 0 and exactly 24 minutes on the stopwatch because her rate is consistent. All right, so now let's figure out the range. Well, my lowest y value is 0, okay? Is less than or equal to y is less than or equal to 4. She could have anywhere from 0 to 4 miles in her journey, okay? She could stop at any moment, and then I would have to calculate her distance that she has remaining. So the lowest distance she's going to have is 0 miles. That means she's at school, and then 4 miles means that she hasn't left her house. She's still at home. All right, so let's look at the next example. The function y is equal to 10 minus 1.5 times the value of x represents the total cost for John to ride x number of rides at an amusement park. John only has $10 to spend. So again, first thing we've got to do to figure out if it's discrete or continuous, because that's going to tell me if I list out my x values or if I have to use inequalities. So I'm going to look at my x values, x number of rides. So I have to think, okay, am I going to leave out when I'm talking about rides? So when you start talking about the number of rides, you say, okay, I've ridden 1 ride, or I've had 2 rides, or I've had 3 rides. So if you notice, when we're counting rides, we're only using whole numbers. So this would be discrete, which means when we list out when we write our domain, we are going to be writing it out using brackets, and we're going to make a list. So let's figure out the number of rides. So he could ride 0 rides, he could ride 1 ride, but you notice he only has $10 to spend. That cost is his y value. That's y. So he's not going to have an unlimited number of rides. So I'm going to actually go to my calculator, and since they gave me the equation, I'm going to type that into my y equals, and I'm going to go to my table and I'm going to look at this because this is going to help me out. So look here. If he rides 0 rides, he has $10 left to spend. So I need to figure out how many rides can he ride to where he either spends all of his money or he rides and just doesn't have enough money to maybe ride again, okay? So let's look here. So if he rides 1 ride, that's how much money he has left, $8.50. At 2 rides, he has $7 left. At 3 rides, he has $5.50 left. At 4 rides, he has exactly $4 left. At 5 rides, he has $2.50 left. And then he can ride 6 rides and have $1 left. But can he ride another ride after 6? And the answer is no, because he only has $1 and each ride costs $1.50. That's why it's being taken away. He's spending $1.50 every time he rides a ride. So at 6 rides, he's done for the day. He doesn't have any more money available. He doesn't have enough to ride again after 6 rides. So I know exactly what my domain is. It's 0, 1, 2, 3, 4, 5, and 6 rides. That's it. That's all he can afford. Now I'm going to look at my range, and I'm going to list out all of the dollar amounts that he has left. So this is going to kind of take a little bit of a list. So he has $8.50. He has $7. He has $5.50. He has $4. He has $2.50. And then finally, he has $1 left. So a little bit more on the Y values. So that is it. He will have 6 rides, and at 6 rides, he'll have $1 left. He can't ride 7 rides, again, because he doesn't have enough to pay for the cost of the next ride, which is $1.50.